Hello coders, I welcome you all. In the last video of this MLOps playlist, we created complete end-to-end MLOps project that you can see here. In this video, we are going to add CI, continuous integration, to our project, which is a very important part of any MLOps project. You might have heard the term CI/CD pipeline, right? That stands for continuous integration, continuous deployment. Sometimes CD also called as continuous delivery as well. In this video, we will focus on the CI part of CI/CD pipeline. First, we will go over the basics of CI. Then we will add it to our project, this particular project. So here in this video, we will discuss the theory first. Then we will move to the practical part. It may happen that those who are learning CI for the first time might not understand everything initially, means theory part. But when I take small simple examples during our practical part, you will easily relate them to this theory that we will discuss shortly. Now, let me explain how to approach this video. In your first viewing, just watch the entire video. In the second viewing, try to follow along with me. You can also access my code on GitHub. So let's get started. To explain you the concept of CI, continuous integration, we have this setup. This is our main code base where the core project resides. Over here, we have a developer, and here is the assistant and a runner space for the assistant. Imagine you are a developer working on a project and you have an assistant to help you make sure everything works perfectly. Now your role as the developer, you decide to add a new feature to the project. After making changes on your system, you push the updated code to GitHub. Now the assistant's job. The assistant pulls the latest code from GitHub to their system. They install all the necessary dependencies to set up their system just like yours, like developer's environment. Then the assistant builds the project to ensure there are no errors. Run the DVC pipeline to check that all the stages working properly. Test the entire project to confirm nothing is broken. If there is any issue, the assistant tells you what's wrong. Means send the feedback or result back to GitHub. You fix the code and push the changes to GitHub again. The assistant repeats the checks until everything works. Once the assistant confirms everything is working, the process is complete. So please concentrate. This constant back and forth between the developer making the changes and assistant testing the project is what we call continuous integration, right? This assistant represents the world. As we just discussed, they install all the necessary dependencies to set up their system just like yours, like developer's environment. If the code works on the assistant system perfectly, right? Okay. In simple terms, CI is like having an assistant who is constantly integrating, testing, and giving you feedback on the code you push. Push is just one event or trigger, right? There can be any other event or trigger as well that we will discuss shortly. This continuous process makes sure that the code stays stable and reliable, saving time and preventing errors, no matter how many developers are working together. I hope you understand something about CI now. Let's understand some important terminology that helps you understand the working of CI, continuous integration. So we are going to discuss these three important terminology that helps you understand the working of CI, like action or trigger. Second, workflow. And third, runner. So let's start with action or trigger. So please concentrate. When the developer pushes their code to GitHub, they are taking an action, right? That is called as an action or trigger. Next, workflow. As the developer, you provide a set of tasks for the assistant to perform after the trigger has occurred. I am repeating, as the developer, you provide a set of tasks for the assistant to perform after the trigger has occurred. This set of tasks or instructions for the assistant is called a workflow. As a developer, you define a workflow, which is essentially a list of instructions that the assistant will follow once your action, the trigger, happens. The workflow specifies what the assistant should do, like building the project, running tests, or checking for errors. As we just discussed, the assistant pulls the latest code from GitHub to their system. They install all the necessary dependencies to set up their system just like yours. like developer's environment, right? Then the assistant build the project to ensure there are no errors. Run the DVC pipeline if required to check that all the stages working properly. Test the entire project to confirm nothing is broken. Now you can see these tasks are listed in the workflow provided by the developer to the assistant. Assistant follow this workflow to execute the task. In simple terms, the trigger is the action like push or pull request made by the developer. Workflow is the list of tasks or instructions provided by the developer that the assistant follows after the trigger happens. Once the tasks are done, the assistant gives feedback to the developer, means it sends it to GitHub back, letting them know if everything is okay, if there are any problems to fix, right? Now let's move on to our third terminology, runner. The tasks listed in the workflow by the developer are performed on the assistant's system, which is called as a runner. You can think of the runner as a virtual machine where assistant executes all the steps provided in the workflow. The developer will decide the trigger such as on push, pull request or schedule time. When this trigger occurs, the assistant executes the workflow. The tasks listed in the workflow by the developer are performed on the assistant's system, which is called as a runner. You can think of the runner as a virtual machine where the assistant executes all the steps provided in the workflow by the developer. The developer will decide the trigger such as on a push, pull request or schedule time, and when the trigger occurs, the assistant will execute the workflow. After executing the workflow, the assistant gives the feedback to the developer, means to the GitHub back. Currently, we rely on the physical assistants, like human acting as assistants, right? However, in the real world, where many developers work on the same project, having a human assistant is not feasible. Instead, we use CI tools like Jenkins or GitHub Actions, which serves as virtual assistant. These tools ensure that every change is quickly tested and validated, keeping the main code base stable and reliable, even when multiple developers are collaborating. Today, in this video, we are going to discuss the blocks in the blue color. This side, this two. So the assistant here in our case is GitHub Actions. Please remember this. As we just discussed, when a trigger occurs, such as a commit, push, pull, or any custom triggers, our assistant GitHub Actions pulls the latest code from the GitHub repository, the main code base, and runs the code on the runner. It installs all the necessary dependencies to set up the system just like the developer's environment. Then the assistant, means GitHub Actions, builds the project to ensure there are no errors. Run the DVC pipeline to check all stages work properly. Test the entire project to confirm nothing is broken. The assistant informs you about what's wrong by sending feedback or results to GitHub. You fix the code and push the changes to GitHub again. And again, same process is followed by assistant until everything works properly. So as we just discussed, set of instructions, also called as CI workflow, given to the assistant by the developer is called a workflow or CI workflow, also called as CI pipeline, which we are going to write in this video. So here we will discuss how to write a trigger and how to write a workflow for our assistant, right? A set of instructions given by the developer to the assistant. Hope all of you are clear with this, right? Working of continuous integration. So let's start with what is CI. CI stands for continuous integration. Continuous integration is a software development practice where developers regularly merge their code changes into a central repository, usually multiple times a day. Each merge triggers an automated process that builds and tests the code to ensure it integrates smoothly without breaking the main project. Main project, which is available inside main repository on GitHub, right? CI helps catch integration issues early, maintain code quality, and speed up development cycles. I hope you understand something. If not, don't you worry. We will discuss each and everything practically, and then you will easily relate them to this theory that we are currently discussing, right? So now let's move on. How continuous integration works. So as we discussed, continuous integration is a practice where developers frequently commit their code to a shared repository. Every time new code is committed, an automated system runs to build the code, perform tests, and check for issues. Here you can understand with CI, we are automating tasks that would normally require human effort. This is helpful because many developers work together and it is not possible for a human to handle everything, especially since they commit at different times and multiple times a day. So we are setting up an automated system that runs to build the code, perform tests, and check for issues whenever developers commit their code to a shared repository. So this ensures that any problems are identified early, allowing developers to fix them quickly. The goal is to keep the code base stable, means our central repository stable and up to date, making software development faster and more reliable. Now to understand this all, let's take very simple example. Imagine we are building a house with a team. In the old way, each builder would work on their part separately for months. Then they would try to combine all their work at the end. This is often led to mismatched pieces and delays, right? So what happens if we are using CI here? So continuous integration is like a smarter way to build a house. Here how it works. First, instead of waiting until the end, builders work together frequently, sharing their progress and combining their work often. Next, every time someone adds a new piece to the house, an automated system checks if it fits with the rest of the building or not. If something doesn't fit, the system alerts the builders right away without waiting for months, so they can fix it quickly. This is exact idea behind continuous integration. So now let's move on. Why CI is important? First, early problem detection. By working together and checking frequently, problems are found and fixed early, saving time and effort. Second, better quality. We are performing automatic check, right? Using our created system, means using our CI flow. So automated checks help ensure the house is built, means our software is built to the high standards. Next, faster completion. CI streamlines the building process, allowing for a faster and more reliable construction. In our case, more reliable software making. Next, improved teamwork. CI encourages collaboration and teamwork among the builders, right? In our case, software developers, right? I hope you understand the importance of CI in software development. So here I have listed some popular CI tools: Jenkins, GitHub Actions, Circle CI, Travis CI, GitLab, and Team Setting. In this video, we are going to use GitHub Actions as a CI tool to execute our CI workflow. But before we dive into that, let's first understand how continuous integration works in the practical scenario. So this is our central repository, our main code base. So the programmer starts by creating a new feature. They do this by either cloning the repository, means our main code base, or creating a new branch from the main repository on their local machine. The programmer then works on the new feature locally. After developing the new feature, the programmer pushes the code to the main code base here in the central repository. Hence, programmer wants to merge it into the main code base. This means they upload their changes from their local machine to the main repository, making them available for integration with the rest of the project. Now, when the pull request is created or when the branch is pushed to the main repository, it triggers the CI workflow, means it triggers the CI pipeline. So the CI system, like GitHub Actions, will automatically pull the code from the central repository to start the process. Then the CI system sets up the environment on a server here. Server is also called as runner. Actually, it is a virtual machine. On this virtual machine, it installs the operating system, install any necessary dependencies like Python, and preparing the environment to run tests and checks. This is necessary to ensure consistency in the environment where the test will run, right? After the environment setup on this particular virtual machine, means on this runner, the CI system runs multiple checks like unit test, integration test, linting, build our code, etc., which is depending on the configuration that we make. Don't you worry, I will explain each and everything practically. How to create CI workflow. Here, CI system performs all this to ensure that the new feature does not break the main code base and is functioning as expected. Now, once the tests are finished, the CI system reports the results to the team. This usually happens through a status update on the pull request itself, notifying the team whether the test passed or failed and if the merge is allowed or blocked based on the outcome, right? So this is to keep our main repository, means our main code base, in a deployable state all the times. This ensures that the code in the main branch is always stable, functional, and ready for production, which is a core principle of continuous integration and continuous deployment. CI/CD pipeline. Hope all of you are clear with this. So this is how CI works. Now let's understand the different tasks performed during CI, during continuous integration. In continuous integration, various tasks are executed to ensure quality, functionality, and reliability. So here are some common tasks in CI. Code checkout and setup. Pull the latest code from the repository that we already discussed over here, right? Pull the code from the central repository to our runner. Install necessary dependencies or packages. Set up environment variables and configurations. Next, code linting. Run code linters to enforce coding standards and identify syntax error or code quality issues that we will discuss shortly in detail. Next, static code analysis. Perform static analysis to identify potential security vulnerabilities and maintainability issues. Next, unit testing. That also we will discuss practically. Execute unit test to verify that individual components of the application work as expected. Next, integration testing. Run integration test to check how different parts of the application interact with each other. This step ensures that the components work well together. Next, build. Compile the code, bundle asset, or create executable files. This step ensures that the code base is ready for deployment or packaging. Next, dependency checks. Verify that dependencies are up to date and compatible. Next, code coverage analysis. Generate a code coverage report to measure how much of the code base is covered by test. Next, artifact creation and storage. Create, build artifacts like jar files, Docker files, and store them for deployment in a later stage. Next, end-to-end testing. Simulate real-world user scenarios and workflows. End-to-end test verify the full functionality of the application. So these are the tasks performed during CI. Next, security scanning. Run security scans on the code base and dependencies. Next, performance testing. Evaluate the application speed and resource usage. This step ensures that performance meets required thresholds. Next, reporting and notification. Generate and send reports on build status, test results, code coverage, etc. to the team. These tasks ensure code quality and application readiness for the next steps, whether it is deployment or further testing. So these are the tasks commonly performed during CI, but it is totally depend on how you create CI workflow. As I said earlier many times, we will discuss all this practically. Hope you understand something, right? So please remember, CI is a highly practical concept. So let's create a simple CI workflow that checks code linting. As I said, we will use GitHub Actions to create this CI workflow. Before we move to the practical part, let's understand what linting is. So linting errors are issues or inconsistency in code that violate coding standards or best practices. Let's take example of Python programming language following PEP 8 The official style guide is crucial for maintaining code quality, readability, and consistency across projects. In the industry, we don't code alone, right? We work as a team. That's why we need to follow the PEP 8 Python standard to ensure that the code format and quality stay consistent throughout the software development process. Linting tools like PyLint or Flag 8 help enforce these standards by identifying and fixing issues. Let's discuss common types of linting errors. Syntax errors. These occur when the code doesn't follow the correct syntax rules of the programming language. For example, missing parentheses or brackets, etc. Next, unused variables. When a variable is declared but not used anywhere in the code. Next, improper indentation. Inconsistent use of tabs or spaces for indentation. Next, naming conventions. Using improper names for variables, functions, or classes like camel case instead of the recommended snake case. Next, line length. Lines of the code that exceed a recommended length, often 80 or 20 characters, are allowed. Next, redundant code. Code that is unnecessary or can be simplified. Next, code complexity. Functions that are too long or have too many conditional branches, making the code harder to read. Next, missing docstrings. Functions or classes that lack proper documentation, making the code harder to understand for others. So these are common linting issues or linting errors. Don't you worry, we are going to create CI workflow to detect linting error or issues. As I said earlier, continuous integration means CI is a highly practical concept. Let's create a simple CI workflow that checks for linting issues or linting errors. So now let's jump into VS Code and create a CI workflow that automatically checks for linting errors when someone pushes the code to the remote repository, which is available on GitHub. And as I said earlier, we are going to use GitHub Actions as a CI tool. So before we create the CI configuration file, let's check for the linting errors locally. After that, we will create the CI configuration file that will check linting errors when someone pushes the code to the repository. Let's first open command prompt. Let's move to E drive and let's create new directory with name CI underscore demo. Let's move inside this directory and let's open VS Code from here. Let's create new Python file with name example.py. Here I am going to write a code that contains some linting errors like this. Unused imports. Let's create one function with name great, which takes one argument name. And here I am giving incorrect indentation. Again, let's create some extra spaces. This is also part of linting errors. And again, let's create new function which performs addition of two numbers. And let's return A plus B. Here I am explicitly creating linting errors, missing spaces around operators. Let's call our function. Let's pass one argument here, any name. Let's print and call this function with two arguments, 3 and 5 for this particular function. Here we are making function call. Let's save this file. Let's open new terminal and let's execute this code. You can see output is hello Anil and 8. We can get the output, right? But pay attention to the format of the code. In the industry, we don't code alone. We work as a team. That's why we need to follow the PEP 8 Python standard to ensure that the code format and quality stay consistent throughout the software development process, right? So others can read and understand our code properly, right? And this type of errors are called linting errors or linting issues. One of the famous tools to find linting errors is Flag 8. Now let's first install Flag 8. You can see in my case requirement already satisfied because I have already installed Flag 8 on my system. Let's clear this and let's run our code with Flag 8. For that we have to write Flag 8 and our file name example.py. Let's press enter. You can see our code contains these many linting issues or linting errors. And you can see it is showing with error codes and line numbers that you can see here. At line number 1, this is error code F401, math imported but unused. In line number 3, with error code E302, expected 2 blank lines, found 1 here at line number 3. Now at line number 4, here with this error code, indentation is not a multiple of 4, which is expected by PEP8 that you can see here. Now at line number 11, too many blank lines, 6 that you can see here. 1, 2, 3, 4, 5 and 6. Again at line number 12, here indentation is not a multiple of 4, which is expected by PEP8. Again E305, which is error code generated by flag 8, expected 2 blank lines after class or function definition, found 1 here at line number 14. Now you can see at line number 15, missing white space after comma here. And here you can see blank line at end of file. So our current code contains this many linting issues that you can see here. Now you can see that we have checked for linting errors using flag 8. And here we executed flag 8 locally. Means we are checking linting issues or linting errors locally. However, we want to create a CI workflow, also called as CI pipeline, that will automatically check for linting errors or linting issues whenever code is pushed to the main repository by developer. This means our assistant will check for linting errors whenever a developer pushes code to the main repository, right? In other words, we are going to set up a CI workflow or CI pipeline using GitHub Actions. As you know, GitHub Actions is our assistant. Whenever we push the code, GitHub Actions will automatically run the CI workflow and check for linting errors, ensuring that code quality is maintained. Hope all of you are clear with this. So now let's move on. So first, let's clear this and we have to initialize Git using following command git init. Now we have to add Git remote. So for that, I am opening my GitHub account. Let's create new repo with name CI demo 1. You can give any other name as well. And let's create repository. Let's copy this URL. Let's move back to VS Code. Git remote add origin and this URL. Let's press enter. You can see now we have made the connection to the remote repository here, which is available on GitHub. Now let's set up GitHub Actions to check linting issues automatically. So for that, we have to create a very important folder, .github folder. And inside that folder, we have to create another folder with name workflows. You have to create these folders with the same name that I am providing, right? Then only GitHub Actions will understand and identify CI workflows. And inside this directory, we have to create CI workflow. Let's give name lint and we have to create YAML file. You can create such multiple CI workflows as well. But currently I am creating only one to check for linting issues or linting errors. So we can create multiple CI workflows as well. Each file represents a separate workflow and you can customize each one to handle different tasks or run on different events. This file will define the steps to automatically check our code for linting errors every time when we push changes to the repository. In this YAML file, we will specify the actions to set up the Python environment, to install the necessary dependencies like flag 8 and run the linting checks on the code. By integrating lint YAML to the CI pipeline, we ensure that linting errors are caught early in the development process, helping maintain clean and consistent code quality across the project. We can customize the CI configuration file according to our requirements. This particular file, lint.yaml, you can give any other name as well. There are many components, jobs, and events that can be used inside this particular file. CI workflow file, also called as CI configuration file. However, For simplicity, we will focus on the sections and events necessary for checking linting errors in this example, right? So once we cover the essential parts, we will expand on other options and events in our next examples. So now let's get started. Let's write our CI workflow, which is also called as a CI pipeline. We can have multiple CI pipelines, meaning multiple CI workflows. But in this example, we are going to write only one workflow. CI workflow contains a set of instructions that our assistant should follow. As developers, we are going to write this set of instructions for the assistant, and it is called as the CI workflow or CI pipeline. To write this CI workflow for our assistant, in our case, virtual assistant is GitHub Actions, right? We have to write it in proper format. So CI configuration files in GitHub Actions typically have three main components: name, on, and jobs. Let's write here as well in our lint.yaml file, name, on, and jobs. To name, let's give CI demo. This section defines the name of the CI workflow. It helps us to identify the workflow when viewing it in the GitHub Actions dashboard. Here is the actions, right? That I will show you shortly. Next, on. Here, let's write push. This section tells GitHub Actions to our virtual assistant when to run your workflow. You can set it to run on different events like push or pull request, right? Push means when you push changes to the repo, means the developer push changes to the repo, or pull request when a pull request is made by the developer, right? Next, jobs. This section defines the task called jobs you want GitHub Actions to perform, means our assistant will perform. Each job has steps, which are individual actions or commands to run. One workflow can have multiple jobs as well. Currently, in this particular example, we are going to create one job only. Shortly, we will discuss how to create multiple jobs as well. First, we have to give name of the job. You can give any. Let's give lint. This is the name of the job. You can give the job any name that makes sense for your workflow. Next, in the jobs, we have to use runs -on. These specify the environment in which the job will run. Here, we are going to use Ubuntu latest, means the job will run on the latest version of an Ubuntu virtual machine, means on runner of our assistant, right? GitHub provides different environments like Ubuntu latest, Windows latest, and macOS latest. But currently we are using Ubuntu latest, right? So as we just discussed, Ubuntu latest means the job will run on the latest version of an Ubuntu virtual machines, means on the runner, right? Here. Hope all of you are clear with this, right? Next, we have to provide steps. Steps are individual tasks within a job. They run one after another and perform specific actions like checking out the code, setting up the environment, or running commands. Steps help break down our job into smaller tasks. Don't you worry. Let me show you this. First, we have to provide name. So here we are going to follow these many steps. First, check out code. As we discussed, so here assistant will fetch or pull latest code from main code base, right? So that we providing over here. Check out code. Next step, set up Python. Next, install dependencies. Next, run flag it, because we are going to check our code for linting errors, right? Now these are our steps, just name of the steps, but also we have to tell what to do for this particular step. So for that, we have two options. One is uses. This tells GitHub Actions to use a pre-built action from the GitHub Actions market space. So uses actions / checkout @v3. This is a pre-built action provided by GitHub Actions. Let me show this. So let's check this. So let's move GitHub /actions. You can see all predefined or pre-built actions by GitHub. right? So we don't require to write it from scratch. So let's click on repositories and let's use checkout. You can see over here. This code performs checkout, means pull the latest code from GitHub to runner, right? As I said, this tells GitHub Actions to use a pre-built action from the GitHub Actions marketplace. That just I showed you, right? And currently we are using version 3. Also you can use version 4 as well. This refers to the checkout action and version 3. Version 3 is the version being used. So here actions /checkout v3 is a GitHub action used to clone your repository into the workflow runner. So we don't need to write any additional code for this. If we use this action, GitHub Actions will automatically clone our repository, means the main code base into the runner space, right? Just you have to recall this. Right? Next. Now we have to set up Python. So again, we have to use this keyword, uses, because we are going to use pre-built action from the GitHub Actions marketplace, right? So that's why here we are using uses. Again, actions / setup -Python @v4. Let's save this and let's move to GitHub Actions market space. You can see here we are using this actions, pre-built action from the GitHub Actions market space, right? To set up the Python on our runner. Next, we have to install dependencies so the runner can execute our code. So for that, we have to use run. So the run keyword allows you to execute shell commands directly on the runner during the workflow. The commands are run sequentially. And here we are using this pipe symbol. This one indicates that the following lines are multiple commands to be executed in sequence. In this case, the two commands will be first, upgrade the peak, because we are setting new machine. So Python -m pip install -upgrade and peak. Second command, we have to install flag 8 on our runner space. Now done. In this case, the two commands will be run one after another. First this one and this one. Now next. Now we have to run our script, this example.py, using flag 8. Again, we are going to use our commands. So we have to use run. If we are using pre-built actions, then we have to use uses keyword. For shell commands, we have to use run keyword. Here we have to execute our script, flag 8 space example.py, our file name. Let's save this. So now you can see we have created a CI workflow instructions for our assistant, and we are telling our assistant to check for linting errors in our code. You can see name of our workflow, when to execute this workflow. In this case, when we push the code to GitHub. Here, setting up the environment with name, right? And currently we are using Ubuntu latest, providing tasks like check out the code, set up Python, install dependencies, and execute our code. Means running our code in the runner space. This sequence ensures the workflow is automated and executed seamlessly, right? By our assistant, GitHub Actions, right? Now let's push the workflow to GitHub. Now let's check Git status. You can see these many untracked files. Now let's add all the files to the staging area. Let's clear this. Now let's commit this code, initial commit. Now let's push our code. So for that we have to write git push origin master. Let's press enter. Now done. Let's move over here, actions. Let's click on the code and actions. Can you see this? Initial commit and which is failed. Let's check this. So currently we have syntax error on line 11. Let's check this. Also, let's give some spaces here for better readability. Nothing else, right? Now let's save our file. So error Because we have to perform proper indentation like this. So these steps should be properly indented like this. Hope you can understand, right? Importance of indentation here as well. Now you can see name on jobs, runs on, and steps inside the job. Again, let's save this. Let's clear this. Now let's check git status. You can see this particular file is modified. Let's clear this. Git add dot git commit -m fix workflow indentation. Let's press enter. Git push origin master. Right? Let's press enter. Done. Let's check on actions. You can see our workflow is running. Let's click over here and you can see lint, our workflow name that we have provided over here, right? To identify our particular workflow, and it will execute these steps one by one. You can see here, setup job. Can you see this? On operating system runner image, checkout code. You can see setup Python, install dependencies, and run flag 8. And you can see over here, our assistant has executed the code as per the instructions provided here. Can you see this? In this particular YAML file, and send feedback or results or output to us. Can you see this? Linting errors. So when the developer puts the code to GitHub, it will check for linting errors like this and notify the developer here, that you can see over here, right? And you can see all these steps that also you can see here as well. Setup job, checkout code, setup Python, install dependencies, run flag 8 that you can see here, right? And this post checkout code and complete job will automatically perform by GitHub actions, our assistant, right? Hope all of you are clear with this. How to give instructions to our virtual assistant, GitHub actions, right? And how to write CI workflow, means instructions for our assistant, and how to write CI pipeline, also called as CI workflow for our assistant, right? Now let's move on. So now let's move to example.py and let's try to fix the linting errors. Remove this unnecessary import. Let's remove these spaces. Require 2 spaces after the function. Same over here. Here we require spaces after and before plus as per pep at standard, and here as well. I think now it works. Let's check. Let's clear this. Let's check git status. You can see we have modified this particular file. Let's clear this. Git add dot git commit -m fix linting errors. Git push origin master. Now done. Let's move to GitHub actions. Done. Let's move to GitHub. Let's click on actions. You can see fix linting errors. Let's click here. Again fail at this time. Still we have some linting errors. Indentation is not a multiple of 4. You can see at line number 3 and line number 7. Also we required blank line at the end of the file at 14. 3, 7 and 14. Now here space multiple of 4. Here as well 3, 7 and 14. Let's save this file. Again let's clear this. Add. I'm keeping the same. Commit fix linting errors. Again git push origin master. So when we push, GitHub actions trigger this workflow. Let's move to GitHub. Let's click on actions. You can see again indentation is not a multiple of 4. Over indented. You can see blank line end of the file. Back this, save this. Let's clear this. Add, commit, and let's push our code. Done. Let's move. Click on actions. You can see now hope it works. You can see starting job, install dependencies. Again to linting errors. Actually it accept this as per pep 8. It should be 4 characters. I hope it works now. Let's clear this. Add, fix push our code. Let's click on actions. You can see here. Now it runs properly and you can see green tick over here. So here we set up Python. Here also we can specify a specific version of a Python to be installed by our assistant on the runner space using the with keyword. So here with, and we have to use this action Python version colon, and here we can specify specific version of a Python like this. Let's save this file. As you can see, we have created a simple CI workflow that runs on a single operating system, Ubuntu latest, right? However, in real-world projects, your code needs to work seamlessly across different operating systems like Windows, macOS, and Linux as well. This is important because different operating system environments may introduce variations in libraries, file paths, and dependencies that can affect the performance or compatibility of our code. To address this, we can enhance this CI workflow to test the code on multiple operating systems as well. GitHub Actions makes this possible using the matrix strategy. Let me show you this. So after here runs on, we have to use strategy, and here matrix and OS. In the list, we have to provide different operating systems like Ubuntu-latest, Windows-latest, macOS-latest, right? So now here, in place of this, we have to write this OS, this matrix dot OS, which is pointing to this particular list, which contains 3 operating systems. Let's save this. Let's clear this. Let's check Git status. You can see we have modified the CI workflow file. Let's clear this. Git add dot git commit -m add multiple OS git push origin master. Now let's move to GitHub. Click on actions. You can see add multiple OS. Let's click over here and you can see here jobs completed 0 out of 3. You can see here 1 out of 3, 2 out of 3, and you can see it is taking time for Windows as compared to Mac OS and Ubuntu. You can see now all done. So we have executed our code on 3 operating systems, Ubuntu, Windows, and Mac OS, and it's working fine. So this approach ensures that your code is automatically validated across diverse environments, providing confidence in its compatibility and reliability that you can see over here. You can click and check here. You can see, and on Ubuntu that you can see over here. I hope all of you are clear with how to test our code on different operating systems using CI workflow. So for that, we have to use this action strategy, matrix, and here we have to provide list of operating systems, right? Now let's move on. So now we have tested our code on multiple operating systems, right? And you can see the green tick marks here, our successful commit. Let's click over here and you can see here as well, green tick marks, and this all runs parallelly. Please remember this. But now we also want to test with different versions of Python as well, not only on multiple operating systems, but on multiple operating systems with different Python versions. Let's do this. So first, here we have to use Python -version. You can use any other name as well. Let's use 3.9, 3.10, and 3.11 as well. Save this code, and here in place of this specific version that we have used earlier, 3.10, now we have to write like this, matrix dot this Python -version that we have used over here, our list name. Let's paste it over here. Let's save our code. Let's clear this. Let's check Git status. You can see we have modified this particular file, git add dot git commit -m add multiple OS with Python versions. Let's press enter, and git push origin master. Let's press enter. Let's move to GitHub. Let's click on actions. You can see our current commit. Add multiple OS with Python versions. Let's click over here and you can see here. We defines two variables in the matrix, right? OS and Python version. So this creates a total of 9 combinations that you can see here. Ubuntu latest with 3.9, Ubuntu latest with 3.10, Ubuntu latest with 3.11, same for Windows and Mac OS as well. These combinations are executed in parallel. Please remember this. Ensuring the code is tested across all specified environments quickly and efficiently. You can see on these environments, Ubuntu, Windows and Mac OS with different versions of Python as well. So this approach provides confidence that your code will work seamlessly on different operating systems and Python versions. You can see in our case, 9 combinations, 3 cross 3, 3 operating systems, and we have used 3 versions of Python, right? Hope all of you are clear with this. And also you can understand the importance of CI workflow, right? Now let's move on. So currently you can see that our workflow is triggered only on a push event, right? But now we also want to trigger our workflow on pull request on master branch. This means I want to show you how to set multiple triggers like push and pull request in our workflow. Let's modify the CI workflow to trigger not only on push events, but also on pull request to the master branch. To demonstrate this, let's create a new branch with name multiplication. You can give any other name as well. And we are going to add a multiplication feature on this branch. So first, let's check branch. You can see currently we are having only one branch. So let's create new branch with name multiplication. You can give any other name as well. Now let's check it once. You can see we have successfully created new branch with name multiplication. But currently we are on the master branch that you can see here. So let's clear this and let's check out to multiplication branch that just we have created. You can see switched to branch multiplication. Let's check. You can see currently we are on multiplication branch. So here we are going to add one new feature for multiplication A, B, and let's return A into B. Let's save our code. Now let's clear this and let's check git status. You can see just we have modified this particular file and we have added this new feature. Now let's modify our CI workflow to trigger not only on push event, but also on pull request to the master branch. So here in place of push, we are going to add pull request as well. So first on push and branches master. Let's add pull request as well. You can see just we have modified our CI workflow that will be triggered not only on push event, but also on pull request to the master branch. Let's save this file as well. And you can see currently we are on multiplication branch and just we have added this particular feature into our project. So now also let's call this with 3 and 5. Let's save our file. Again, let's clear this. Let's check git status. You can see we have modified these many files, right? Again, let's clear this. Git add dot git commit -m add multiplication feature. Now git push origin and this particular branch, right? So currently we are pushing on multiplication branch, not on the master branch. Please remember this. You can see. Now done. Let's check on GitHub. You can see. First, let's move to GitHub actions. You can see our workflow has not triggered yet because we pushed to the multiplication branch instead of the master branch, right? Now let's back and let's click on pull request. Here, let's add multiplication. You can write multiplication feature has been added. Now let's click on create pull request. Now let's check on GitHub actions. Can you see this? Our CI workflow has now been triggered on the pull request that you can see here. So this way you can trigger your workflow on push and pull request to the master branch that you can see here. Let's click over here and let's check why this failed. You can see this workflow is failed because of this linting error. You can see line number 9. Let's check this. Okay, and please read this linting error properly. You can see expected 2 blank lines, found 1 here. After this function, let's save this. Git status, git add dot, git commit fix linting error. Let's clear this. Again, let's push on multiplication branch. And you can see here, now our jobs are running perfectly. You can see here. I hope all of you are clear with this. How to set multiple triggers like push and pull request in our workflow. Now all done. You can see 9 jobs completed successfully. So this way we can set multiple triggers for our workflow. So now our workflow will be triggered not only on a push event, but also on the pull request as well, that you can see here. Hope all of you are clear with this. So now let's move on. Before we move forward, let's merge our multiplication branch into the master branch. You can see that we have created a new feature for multiplication on the multiplication branch. This particular feature for multiplication. And you can see currently we are on multiplication branch. To merge it with the master branch, we first need to switch to the master branch. So for that, we have to write following command: git checkout master. Let's clear this. And you can see currently we are on master branch. And here you can see we can't see multiplication feature because we have developed multiplication feature on multiplication branch. So now let's merge multiplication branch with the master branch. So for that we have to write git merge multiplication. You can see here we have successfully merged the multiplication branch into the master branch, right? Also, let's put the function calls inside this name equal main, then only execute these statements. Let's save this file. Now done. So let's move on. So let's move to our CI configuration file lint.yaml. And you can see that currently we have only one job, right? With name lint for linting issues or for linting errors. Now we are going to add one more job for testing. Actually, there are many types of testing, but we will use unit testing. Unit testing is testing small parts of your code like functions or methods to make sure they work correctly. So this is our first job. So this particular job will check for linting errors, and we are going to create our second job that will perform unit testing. Let's move to example.py. So you can see that we have this code with 2 functions. We are considering only these 2 functions, right? One for addition and another for multiplication. So we are going to create a job that will perform unit testing for these functions. For these 2 functions, addition and multiplication. So let's create a new file test_unit.py. So here test_unit.py. I have already created a very simple code for unit testing. And here is the code that you can see. Let's visit this code once. So here we have imported unit test module, which is a Python framework used to write and run test. Now here we have imported add and multiplication modules from this file, example.py, this one. And as you know, which are the functions we want to test. Now here test class. We define a class called test math functions here, which inherits from unit test.test case. And as you can see, this class contains test methods that will check if our functions add and multiplication work correctly. That you can see here. Our first method, test_add. This method tests the add function. And you can see function call for add function. So this function call will call this particular function. And as you can see here, we have used assert equal function to check if the result of editing 2 numbers is correct. You can see 10 plus 20, output will be 30. 1 plus 10, output will be 11, right? So here assert equal checks if adding 10 and 20 gives 30. If it does, the test passes. If not, the test fails. Same here as well. and same for multiplication as well. So just remember, assert equal method compares two values: actual value, the value returned by the function, and expected value, the value we expect the function to return. So if the two values are equal, the test passes. If they are not equal, the test fails and an error is shown. Finally, we are calling this main function. Unit test.main runs all the test methods defined in the class. In our case, these two methods. This will automatically run our test when we execute the script, this particular statement. So now let's first perform unit testing locally. Then we will add it to CI workflow. So first, let's clear this. To run this, we need to use the following command: python-m unit test and discover. So please remember, by default, unit test discover, this one, will search for test files in the current directory and its subdirectories that match the pattern test.py, means files start with test, and run the files with the name test. Let's press enter. You can see ran 2 tests. Output is okay. Now let's change it to 20. Let's save this file. Let's clear this and let's run one more time. You can see run 2 test failed, failures 1, that you can see here. I hope all of you are clear with how unit test is working, right? Let's change it to 30. Let's save our file. Let's clear this. So now it's working properly locally, but we need to add this to the CI workflow. You can see that currently in our CI workflow, we have only one job named lint. Now let's create another job with name unit_test. Let's click here and let's create job with name unit_test. You can give any other name as well. Again, runs on Ubuntu latest, only one, right? And again, same steps, name code checkout. Here we have to follow same steps. Another, here also we have to set up Python and run unit test. So here we are creating a different job with name unit_test. We have already one job over here to check for linting errors with name lint, right? So here we are creating a different job, right? And here is our previous job with name lint. But please remember, here we are creating a different job. So we need to do a code checkout and set up Python. However, installing dependencies is not required because unit test is an inbuilt module in Python. We just need to run the unit test. So now uses actions checkout v3, uses actions setup Python v2, and let's specify specific version, Python version 3.10. And now let's run unit test. Run python-m unit test discover. Let's save our file. You can see that we have two jobs now. This is our first job with name lint, and this is our second job unit_test. Let's clear this. Let's check git status. You can see we have modified this many files. Let's clear this. Let's add it to staging area. Git commit -m add unit test job. Let's press enter. Again, let's clear this. Git push origin master. As you know, when we are doing this, GitHub actions trigger our workflow, this particular workflow, right? So let's press enter. Now done. Let's move to GitHub. Let's click on actions. You can see our commit, which is failed, and you have an error in your YAML file. Syntax error, line number 38. Let's check. I think again we have to format our second job properly. Let's do this. I think now we have formatted code of our second job properly. Let's save this. Let's clear this. Let's check git status. You can see we have modified this particular file. Let's clear this. Git add dot git commit -m fix errors in YAML file. Let's press enter. Done. Now git push origin master. Let's press enter. Now let's move to GitHub. Let's click on actions. You can see our latest commit, fix errors in YAML file. Let's click over here and you can see done. You can see green tick mark and you can see 9 combinations. All are working properly. So please remember, these jobs are running in parallel. Now all done. You can see 9 jobs completed. Let's click over here and you can see all done. So now let's move to VS Code. So now you can see we have 2 jobs, lint and unit test. For linting errors and for unit testing. These 2 jobs are running in parallel. But what if we want to run them sequentially, one after another? First, we want to check for linting errors and then we want to perform unit test, right? So we want to run these 2 jobs sequentially. First, we want to check for linting errors and then only we want to execute this particular job that will perform unit test. So here we have to add one parameter in our second job with name needs lint, this particular job lint, right? So please remember, to achieve this means we want to run these 2 jobs sequentially, one after another. We need to use this particular parameter needs, and here job name, this job name lint. So we can specify that unit testing requires linting to be completed first. So this way the unit testing, this particular job will only start after the linting job has successfully completed. Please remember this, right? Let's clear this. Sorry, we have to save this file. Again, clear this. Git status. Let's clear this. Git add needs parameter. Now git push origin master. Let's press enter. Now done. Let's move to GitHub. Let's click on actions. You can see our workflow has been started. Let's click over here. But now you can see lint and unit test both are connected sequentially. And here you can see unit testing requires linting to be completed first. You can see. So this way unit testing job will only start after the linting job has successfully completed. That you can see. You can see now first job means linting has been completed. Then you can see after that unit testing is also completed. So this way we can execute different job sequentially with this particular parameter needs. Hope all of you are clear with this, right? Now I am sure you have a clear understanding of how to create a CI workflow, also called as CI pipeline. So if you have any doubt or query, I recommend first rewatch this video and practicing it on your own machine. I hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.